Concluding with the ankle, as we see here, the tibia and fibula run down into this super complex region. Now, what's going to be important for us is to see that this area is actually the most congruent joint in our entire body, which is why it's often referred to as a mortise. These joints act together to produce 3 degrees of freedom. There are multiple joints in here, and we're not going to be discussing all of them. Look at them. It's too much. We're going to be discussing a great deal of these, but it's important for us to see first the talocrural joint, this first contact of the tibia with, in here, if you can see this, this talus is a ball bearing upon which the tibia is going to be having its, if you can come now, follow me over here, flexion in this direction. If you come back to the diagram, we see that the outside of the leg has this fibula. Now, as this joint, you can see this here, it will act as a piston. The fibula only carries 10% of the body weight. It's not structural support. The reason that this is here is to pull in, the tendons pull in together to clamp down on this mortise. So if you want to think of it this way, this is the way it should be thought of, this is a wrench clamping down and holding, pincing these two together. In the back here, you see the calcaneus, this huge protrusion at the end of the foot. We can divide the foot into the hind foot, the midfoot, and the forefoot. We're going to concentrate mostly on the hind to midfoot area. The calcaneus rises up through here with the calcaneus tendon, often referred to as the Achilles tendon, but it's going to take us away from our anatomical, physiological perspective on how the foot functions if we start using antiquated terminology. This burst size is going to be important. We're not going to talk about it, but it's going to be important when we start applying pressure to it and exploding it. But you can see here in this joint at the end of the calcaneus that the ability of the foot to create an arch, this strut formation as the forefoot and the hind foot flex towards each other, if you can come to Mike, as these flex towards each other, this will relieve pressure back here. We'll see this as you try and cause a hyperextension here. The flexion in the forefoot is going to relieve the pressure in the midfoot. So we're going to be, just put these up for a second, working on drills that will develop that kind of strength. When you start to develop the tensile strength and compressive strength in your foot, you're going to become more and more impervious to submissions. So go get the Grappler's Toolbox and the new Grappler's Toolbox partner drills. All right. Now, what we want to do is take a look at the ligamentous contacts. In just a moment, we'll go further and see how this impacts the motion of the rest of the leg architecture. It's important for us to understand the ligamentous connections that articulate throughout this region. We're not going to go through and concern ourselves with the names right now at this moment, but what we do need to realize is that the lateral and medial connections are what cause this unique triplanar motion. This is not the function of one joint. This is a function of 3 different joints in unison. However, the component movements cannot be broken down because they don't occur independently. This inversion and eversion, this flexion, and the rotation, which is now, there's play right now. This adduction, abduction. This triplanar motion is going to be important for us in knowing how to properly load the joint. If we come back to here, we also understand that tension in the 2 tendons that we're going to focus on in the region, the calcaneus and through here, if you can see this rising up along here, this peroneus tendon. This sheath can still have pressure being applied. Everyone's familiar with the Achilles tendon because of its inappropriate terminology. However, if you see that this cavity here, you can apply pressure to this, and this is going to cause a great deal of pain in our partner. However, and it's important to realize this, when you have the ultimate grappling shoes, Uggs, it's virtually impossible to apply the same amount of pressure and solicit the same amount of pain because these Uggs are so tremendous that it makes you impervious to everything, not only with submissions in the ankle, but the rest of your body. Now,
and they'll make you stronger in your deadlift.
So, what we've done now is we've found our way through the entire body, from lunar plexus to toes, in a structural and nervous and muscular format. This architecture will lead us into the next section with a blizzard of technical examples when we introduce Monkey 3. We'll begin to look at how we can now start using a flurry of tricks once we know the architecture of the leg. The first is going to be first addressing, now we see the calcaneus bone here and the calcaneus tendon running up here. As we see this, right now, there's play between the calcaneus and the tibial bone. As force is applied here violently, we can either rupture or, more importantly, avulse this tendon by tearing it off the calcaneus. That dysfunction, that dysfunctional strategy will be important for keeping him from following us. However, this tendon can be super strong here, and as you apply pressure, you'll actually be breaking the joint, tearing the joint sometimes before actually rupturing or avulsing this tendon. What'll be important for us is seeing how certain positions will affect the application of pain and injury. So let's start with, let me start it right here. I brought in Monkey 3, Bad Brad, to help us. If we are to have this biomotor interference and irradiate outward, the first thing we have to do is control his lunar plexus. I'll go this way. I'll start this way. To control his lunar plexus, we have to get something up remotely close. So this leg is now upwards. Anything that happens subsequent is communicated through this leg. Now I'm going to turn, remember that as I switch to the other side. The closer this is, the more that we can even have residual pain on the groin. But the closer it is, we've also rooted in to his lunar plexus. This shouldn't be held so statically outwards. Bring this over and downwards. As it is here, now with the back you're controlling the lunar plexus, with the top you're at the hip joint, with your knees you're isolating the knee, with your arm you're at the ankle. As we're here, we can apply pressure to the calcaneus tendon. Everyone knows the Achilles, everyone believes they know the Achilles tendon submission. However, it's such a gross application that people don't realize how to maximize pain. That's why most people don't get it and they abandon it. You can get it in class when you have a willing partner, but somebody that struggles, you tend to use too much effort. So, to use no effort, what we're going to do is we're going to flex abductively while pinching in the opposite direction, pull this heel down, press this foot up, and bring the hips up and forward. As you do this, I want you to begin by rolling your shoulder back to take out the play in the forefoot. As you take out the play in the forefoot, by rolling your shoulder back, you're already loaded on the arm to apply pressure from the hip. So as you thrust, you can cause pain. This can be all day. You can, relax, Brad. You can apply much more pressure with your body than you can with your arm. Now there are important factors here. If he brings his leg up to kick me, just by placing this here, as he kicks, he's going to cause my foot to go down. So if I tense, now bring your kick back, if I tense the muscles around my knee, as he presses this down, it presses the knee down onto his knee. So as he kicks, or as he tries to kick, it's going to cause more pressure to him. So he's submitting himself. Keep kicking me. Quit submitting yourself. Quit submitting yourself. Okay. This is an important factor. Now, if we spin around this direction, and just lay down. If we spin around this direction, and bring your knee up for me. Turn over that way. That way. I want you to see that you can apply residual force by rolling the shoulder back and pinching the elbow down. You'll hear some people say that it's impossible to get the calcaneus tendon, well, they'll say Achilles, if you're not 90 degrees to the tendon surface. If you divide your hand, your forearm into 3 sections, relax your leg, 3 sections, 1, 2, and 3. The minimal amount of meat is in this region, in your wrist. You should have super strong tendons and bony structure in order to apply force. As you pinch your arm, you're going to cause an inversion. This is going to cause a slight insufficiency in this tendon. As you do, the outward pressure, you're coming up and out. This is different than rising pressure. This is a gross motion. It's a very basic way of doing the calcaneus tendon submission. As you rotate in and out, you're going to cause much more force. I'm just doing arm force. I haven't used my body yet. If I use my body, you can rupture the tendon. Also, now we've moved into a different type of submission by rolling back on the foot. By rolling back on the foot, I'm going to roll my forearm down so that this blade isn't pointed up into the tendon. As you roll the shoulder back, now you see that you're taking the foot and hyperextending it. So, as he, pull your toes back. As we roll our shoulder backward, we can cause a different type of submission, which is now not tendon, but ankle. And you can switch back and forth. Tendon, ankle, just by rolling along the surface. Turn inward and roll your shoulder backward to cause a hyperextension. Turn upward and roll outward to go back to tendon. Now, once again, I'm not isolating this area because I want you to be able to see this. Don't work on submissions or dysfunctions without isolating the rest of the body. If you cause pain without, let me do it this way. If you cause pain here, it's to cause hyperfunction, to cause him to move, to change to something else. Now, once we're in this position, we've seen that he's rotated outward. That doesn't change anything from the application of pressure to this tendon area. You can still apply force down on the tendon. You don't have to try and wrench further and start applying force to the knee. The force does not have to be at 90 degrees. As long as you have the structural application, you can continue to apply force.